Hi, welcome to the Git compare and merge in xtML project presentation / demo. My name is Robert Inkert and I'm a member of the Ericsson's model-driven workflow team. Regarding the objectives of this demo / presentation, first we want to provide you an overview with the merge process and the bridge point in the xtML2. We also want to briefly discuss the ways to do a conflict-free distribution of work among team members in a distributed environment, and also to show you how on practical terms conflict resolution can be performed, and for that we are going to use class and state machine diagrams as scenarios. Agenda: we will briefly start with the structure of the xtML project because it's very important to understand how it looks like in order to be able to avoid conflict scenarios, conflict problems. Then we will continue with brief explanation of how Git compare actually works. We'll also show you a merge tool, a brief overview of how it looks, and when exactly bridge points xtML compare tool provider is actually called. We will also briefly discuss safe distribution of work so that conflicts can be avoided, and we will finalize the presentation with the few demos regarding how conflicts can be resolved in the merge tool. So this is the slide about the structure of an xtML project. Projects are usually composed of packages. Within we can have components, classes, and other XML model elements. Basically, packages can hold components, class diagrams, interfaces, data types, etc. Furthermore, components provide interfaces, and they usually contain implementation packages which are actually class diagrams. So basically, in this term, a package will be a class diagram. Also within the class we can have an instance or a class-based state machine, and interfaces are special model elements as well as ports. So on the right you can see a structure of a typical xtML project which we are going to use in this demonstration. It's also important to understand how the xtML model elements are actually represented in the file folder way. For example, package, to which a parent model element type can be another package or a component, usually has its representation as a folder in XTML file. Another example is a component which also has a folder in which an XTML file is contained. The same is with class, state machine, interface, and almost any of the XTML model elements except for the data types and external entity. Where it's very important to understand that rename of a model element is currently a very dangerous operation as regards to the compare and merge, because currently rename is actually done by deletion of the old element, creation of a copy of it with the new name. So basically this is not a compare and merge nice operation, so one needs to be aware of this fact. So plan your rename operations in the model version control system very carefully. Let's go briefly to the bridge point just to illustrate this file folder structure. So basically here we have a model explorer. The project is named compare and merge demo, and within it we have 4 packages. We can go into the navigator just to show you how this looks like in the file folder structure. So within the project folder we have a models folder, and then the project has its own name, and within this we have packages. For example, package demo class diagram has a folder and xtUML file within it. Let's go back to the Model Explorer. This is this demo class diagram, which contains two classes, class 1 and class 2. We can open in the xtUML editor. So basically you can see that within the demo class diagram we have two new folders representing the classes. So basically each class has its own folder and another xtUML file. File and folders are named as the name of the class. So one needs to be careful when naming the xtUML model elements. Let's get back to our presentation. Let's discuss briefly how git compare works. Basically, it's a three-way merge in which three files obviously are used: file 1 and file 2. For example, file in the master branch and file 2 in the slave branch, and their common ancestor. What needs to be understood in this view is that we basically have incoming and outgoing changes. And outgoing changes is something that's been done in the master, so in our local or left side. In this case it's a master, and that the slave or remote is not aware of. For example, if we added a class in the master that the slave is not aware of, it's going to be represented as an outgoing changes in the process when we merge slave into master. If we look at it other way around, so basically if we merge master into slave, this is going to be an incoming change. So what we have added into master and the slave is not aware, it's going to be an incoming change to any operation that will merge master into slave. To be more precise, any of these incoming or outgoing changes can be either incoming addition or it can be addition or deletion, as illustrated in this figure. This is slightly more detailed representation of what's been already said. So basically, when we have something blue, when we have this blue icon or glyphs, they denote incoming differences or incoming changes, and dark or black glyphs denote outgoing changes. Or to be more precise, we can also have red glyphs, which actually represent conflicts. What we usually in xtUML don't distinguish is between incoming conflict and outgoing conflict differences. So basically we just if we find out about the conflict, you usually only this simple glyph. Now let's move to the branch tool. Let's give a brief intro how it looks like. So basically, whenever we merge or rebase, and please note that rebase is just another form of the merge, if we hit conflict, so if there are some changes, we are actually noted by the tool in the model compare. So basically we have a glyphs. So one also needs to be aware of the fact whether we are merging master into branch or a slave into other branch. So here we also show you briefly a legend. So after a merge or rebase process or cherry pick process, these glyphs actually illustrate whether there are conflicts or whether something has been modified or added and staged into the existing branch to which we merge something. Briefly, how the merge tool looks like. Basically it's composed of three parts. First part is structure compare, which actually shows in which files there are changes or conflicts that needs to be taken care of. We can double click on any of the files, and usually it's a good way to browse or to go over all of these files. So visit all of these files. After you double click on the file in the structure compare, then this file will be opened in the structural differences part of the screen, which shows which elements are problematic. So whether we have an incoming or an outgoing change or conflicting change. For example, this screen shows that we have one incoming and one outgoing change. So basically dark or black element, it's an outgoing change. So basically something which we have on the left side and which is not available on the right side. And please note that we are merging right into left. And blue is actually denoting something that is not available on the left. So basically it's a incoming change. Also note that all the incoming conflicts or outgoing conflicts will be red colored. Let's briefly discuss about the scenarios which would not produce any of the conflicts. So basically if users are working on different packages, then no conflicts would result. Whenever we merge, this merge will be done automatically because a different set of files and folders have been modified. The same is with components, classes, state machines, whether they are instance class based or different interfaces. But regarding the interfaces, one needs to be very careful because interfaces are usually formalized, and basically that means that they are formalized as the ports in components. So addition of operation and signals to the ports is relatively safe, but deletion or modification of operations and signals can be a risky operation and can result in the loss of all code. Nevertheless, that's why we have a versioning system. You can always go back and find your lost OL code. Regarding the different ports, these are parts of the components, and as they are placed in a single file, so their compare and merge is relatively safe operation. Once again, please note that the movement of a model element in a package is modification of the package. And please also note once again that the renaming of the model elements in many cases means deletion of the old representation file and folder and creating a copy of it with the new name. Before we move on our demonstration or our scenarios, I'll briefly illustrate typical workflow. For example, we have a product, and product is usually or its source code is actually delivered on the delivery branch, and feature development is actually distributed among many projects. For example, we assumed here we have a project A, and for that purpose we are using project A integration branch. We can also have another project B integration, which we'll not look at this point, but we will focus on the highlighted area on the screen. So basically we will assume the implementation of a feature, let's call it feature 4, and resolution or resolvement of the issue number 5. So basically from that point illustrated on the workflow, we will branch off two branches, feature 4, F4 and I5, and this will simulate the parallel work on both feature 4 and resolvement of the issue 5. Let's have a more detailed look on what we are going to see in the demonstration. So we will spin off two branches from integration in project A. F4, which does some changes and finally delivers to the integration, and then we merge into integration. This is illustrated by this point, and after we merge feature 4 into the integration, project A integration, we will also merge all the changes needed to resolve the issue number 5 into the integration. The first merge of the F4, feature 4, will be fast forward, so basically no problem will be there, but the conflict will happen when we merge I5 into the project A integration. So let's start with the demos. Let's start with the class diagram operation attributes. So basically in two branches we add and modify names, operations, attributes, and we will add some classes. So let's move to the model explorer. Here we have a class diagram which we are going to use for our demonstration. Before we continue, let's create two branches, just as we illustrated. So first branch will be called feature 4, and the second branch will be called issue 5. We will not check out, and we will remain in the checking out feature 4 branch. So let's assume that in resolving or implementing this feature, we added a class. Let's call it class feature 4. Perhaps we added an association between class 1 and class feature 4. Perhaps we've modified the relation number 1. So, for example, instead of having the unconditionality, and conditional, we put the conditional. Let's add some operation. We can also add a attribute here. And we can add some operations and now let's assume that this completes the implementation of the feature 4. So we will add all to index and then make a commit. We call this commit feature 4 implemented. Now let's move on to work on issue 5. So we'll check out that branch. And let's assume that we also needed to add another class. Let's call this class issue 5. Let's also add an association. We can also modify the relation number 1. For example, on the class 2 we can set the multiplicity to many instead of 1, because for some reason we needed this to resolve our issue. We can also add an attribute here. We can also add an attribute and operation here and here. And let's assume that this completes resolution of the work on the issue number 5. So we also, as in the previous case, need to add to index and make a commit. Okay, so what we need to do now is to deliver first feature 4 and then issue 5 to the project integration branch. So in order to do that, let's check out the project A integration. Perhaps this will be done by the integration manager. Then we will merge the feature 4 into the integration branch. Clearly, as previously stated, this is going to be a fast forward because feature 4 was direct descendant of the project A. And now issue number 5 is not a direct descendant of the project integration. So basically, when we do the next step, when we merge issue 5 into now newly modified integration branch, we will hit some conflicts. So basically this is the result of the merge process, and clearly this is demonstrated in the Model Explorer. As previously said, these red glyphs actually denote that there were some conflicts. So we have conflicts on the class 1, class 2, we also conflicts on the class diagram. So basically it's safest to right click on the project in the Model Explorer, choose Team and start the Merge tool. Merge tool is actually an Eclipse part of the Deget, which will eventually call breachpoint's xtUML aware compare provider. So it is always safe when we first start the merge tool to use head, so use this option. If you wanted to do the merge process in several steps, basically you will do some merging and then save, and then you will use this workspace version of conflicting files as an option. But if you start for the first time, always use head. And basically this is the merge tool. So as said, in the structure compare we can check that we actually have conflicts on 3 files, class 1, class 2 and demo class diagram, which is a package or a class diagram. For each of the file, if you double click, you can go to the structural differences and to see what are actually overview of the changes or conflicting changes in the left and right. Remember, on the left is our integration branch and on the right is our issue branch. So as previously said, the blue are incoming, and in this way this is illustrated here. You can double click in the structural difference. It means incoming addition, and this is an outgoing addition. So basically we have only additions as an incoming or an ongoing changes. What we want to do is here is, I guess, copy this incoming change. So basically we will select it either by double clicking here or selecting it here, and select this, copy select difference from right to left. Basically that's it. Don't forget to save, and let's move on to the next file. So similar to the previous case, we also have one incoming and one outgoing. This is an incoming change. We will copy it and save. And finally, let's go to the final file. Here we have structural differences, relation 1, relation 2. So the problem is we have here conditional, and here we have an unconditional. Depending on whether we want to keep left or right, we will or we will not copy selected differences to the left. Let's assume that we want to copy that, so we will select it and then copy it. Whenever we do change in the merge tool, a provider is actually recalled and new changes are actually recalculated, so be aware of that. The other changes, we have a multiplicity which was on the left set to 1 and on the right to the many. Let's assume we want to copy what we have on the right, so we will select this and copy. And finally we can check, we have two relations, relation 2, they are both number 2. One on the left is between class 1 and feature 4, and on the right is between class 1 and class issue 5. So basically we can copy, select and copy to the left, and obviously we need to save it. And basically that's it. We resolved all the problems, and this is how the diagram looks after the compare and merge. If you look at the problems, you will find that we have a number of issues. So another class with the same package has been found with the same number. So basically we have two classes with the same number, so we need to modify the number of one of them. Let's modify the number 4. And another problem is we have an association with the same number, so we also need to modify association number of one of them. So let's modify this one, and basically that completes the compare and merge. What's been left to do is actually to add everything to index, which will denote to Git that we are done with merging, and perform a commit. You can modify the commit message, but since we are not doing a demo on this, we'll skip that part. Okay, that was the demo regarding the class diagram. The next demo is about state machines and the OL code. So we will have a state machine with simple state machine, and we will do some changes in the different branches. Let's move back to the tool, and for that we are going to use this state machine. Similar to the previous, we will create two branches. Let's call them feature 6 and feature 7. We'll not check out this branch. So let's assume we are now checked out in the feature 6, which means that we are working on this feature. Let's assume that implementing this feature means addition of this state. We will also, for example, delete this transition. Instead of we will move here, we can add this transition, self-transitive transition like this. And let's add self-transitive transition like this. Let's now assign events. So this will be event 4th. This will be event 4th. Let's assign this 4th as well. And this will be event back. And let's assume that basically that implemented the feature 6. Let's add it to the index and make commit. Okay, so feature 6 is now completed. Now let's simulate parallel working on the feature 7. In the feature 7 we will add two states. So let's call one feature 7.1, and let's call another one feature 7.2. We will also in this delete this transition, and let's add this 4th event going to the feature 7.1. This is going to be 1/4 again. And we can also add self-transitive 4th, or back and lead us to this state. Okay, let's assume that this completes feature 7, implementation of the feature 7. Let's add it to index and let's commit feature 7 completed. Okay, let's simulate once again delivery of features 6 and 7 in that order to the project integration branch. In order to do that, let's check out the integration branch, merge the feature 6. And please note before we do next merge that there will be a conflict between the transition from state 1 with an event fourth to either state feature 6 or state feature 7, as will be shown when we start the merge tool. So let's merge. Obviously we have a conflict. We start the merge tool and we see that basically there is only one conflicting file. So let's increase that merge tool. So basically now we have a conflicts. Basically from state 1 on the left we go to the state feature 6, and from state on the right from state 1 we go to the feature 7 1 with the same event, with event fourth. So basically that's a conflict. So beware of this. If you choose to do nothing, so if you choose to accept what's been on the local side, so to transit to state feature 6, then basically you will not do anything. But be aware of that, because transition and eventual OL code basically which is available on the feature 7 1 transition, it's going to be lost. So if you don't want to lose the OL code, basically a good thing would be to copy the conflicting difference from remote to the right, which is going to be done by us. Now the changes are recalculated and now we have an outgoing change. So basically something that's remote is not aware is this no event transition between state 1 and state feature 6. So basically in the new solution this is unassigned event, as it's going to be shown. Let's go further. You can use the merge part of the screen or the structural difference to browse through the conflicting changes. So basically we can do something like this. In this scenario we are not going to copy from right to left. So basically we want to have a transition as on the left. So we will ignore this transition between from state to the feature 7 to with the fourth event. And please be aware that this transition is going to be lost from state 2 to the feature 7 2. If you remember, this is the feature 7 2 state, so basically we will lost that transition, and we are doing this on purpose. And as last change we are copying this incoming change. And basically this concludes our job regarding the compare and merge. Save, and let's see what we have got. So regarding this, remember it was a conflict between this or this, so a transition between state 1 to either state feature 6 or feature 7 1. We've chosen to copy it from the left, so from the remote. And another change was from state 2 to the feature 2 with another event. So basically we've chosen not to use this conflict. So basically this is the resolution of the compare and merge process for this state machine. Okay, the last as always, step is add to index and then to commit. We also see that there are some problems, obviously, because two states have the same number. So we will change the number of one of these states, and in order to check this out, we are not going to create a new commit, instead we are going to amend. Okay. And let's move to the final demo. Here we're going to show the port OL code. So we are going to use a component and port OL as a starting point, and then we will simulate addition of the OL code in two branches. So in order to do that, we are going to use this package called demo port OL and the component named one. There's a one port, and we have operations A and signal A, which are going to be changed. So, but before we do that, let's go back to our history view. Let's also create two branches. So let's call first branch issue 8, and let's create another branch. Let's go issue 9. So we are not going to check out this new branch, instead we are continue to work on the issue number 8. And let's add a code here. Let's not do anything more complicated than this. And on the signal B we can do something similar. And let's assume basically that that completes our work on the issue number 8. So let's add it to index and then let's commit it. Now let's move on and work on the issue number 9. So the starting point for the issue number 8 and 9, we didn't have any OL code for the operation A and signal A in this port of the component 1. So let's do something similar. Save it. Let's assume that that completes our work on the issue number 9. So add to index. And commit. Finally, let's simulate delivery of whatever was done for the resolvement of the issue number 8 and 9 into the integration branch. So let's check out the integration branch. Let's merge the issue number 9. This is, as always, fast forward because it's a direct descendant, and then merge the issue number 9. And obviously this will create some conflicts. So let's start the merge tool from the top of the project once again. Here we have only one file which is in conflict, and basically we have conflicts on the operation A, signal A, What I want to demonstrate here is basically process merge tool on the text level. So basically, instead of working on the xtUML model element level, you can double click and a text editor will be copied. So basically you can do here whatever you want. If you want to keep this part, you can copy it to the left. So for example, you can add something new. Here as well. So, or you can just copy everything to the right and then edit the code. Basically, when you're done, same as previous, you save the changes and then as usual add to index and then make a commit. And basically that concludes our final demo regarding the port while. Remember when working with the port while, since all the OL code is kept in the same file, the resolution of complex is basically comes down to text compare and merge, and it's much easier. So what's next? As a finishing point, the biggest drawback of the current process is actually that the Deget, which is an Eclipse plugin, currently supports only file by file compare and merge. So basically whenever a Git tries to perform the merge, it does this on a file by file basis, and whenever we want to resolve this tool, basically we need to select the file or xtUML model element, and only then is actually a breakpoints xtUML where compare provider called, which can do all the intelligent work behind the scene. This logical model facility will strongly change that, because it will allow more than a single file context to be provided to the compare. So basically more complex compare and merge scenarios will be available. Okay, thanks for listening, and that's all.